I created this template to follow the work that you're probably doing with actual red and yellow discs for the kids to act out addition, multiplication, or subtraction of integers. Once you finish with that, then you can go to this template. Now you'll notice that the template is in gray and white, or shaded and unshaded discs. If you've used the red and yellow, you can model answers with red and yellow. The gray ones, or the darker ones, represent the reds or negatives. The yellow, or the lighter ones here, represent the positives. Sometimes, if you want to be real fancy, you can use the infinite cloner and clone the yellow and the red discs. Other times you can do what the kids would be doing with their communicator, which is to just use X's or lines or whatever on their communicator. So let's check this out. And again, as always, if you click on print, you can print the PDF file and copy it for the kids in your class. Every kid should have a communicator with this template inserted into the communicator. And again, they should have had the background that we just discussed. But if you want to model some of these answers, you can model. Let's say I want to add a positive 4 to a negative 3. So if I model this problem, let's see how I could do that. Now, if the kids are doing this, you can do the same thing, have the kids model it, and then show the answer so you can see if they get the right answer. And then you can act it out. Let's see how we would act it out with X's. Now, it's best if the kids use X's rather than fill them in, only because it takes a shorter amount of time. It doesn't use as much time up. So remember, the lighter ones are your positive values, or your yellow discs. You've now got a positive 4 represented because I've X'd out 4. I need a negative 3, so I'm going to put X's on negative 3. There's 1, 2, and 3. What is really cool about this is we've talked to them probably about 0 pairs. You can remove the 0 pairs from your model here. And whoops, I didn't grab them all. All right, let me try that one again. Let me get a little bit better with that. And we want to grab them all, and now move them down. And now what I can do is make them all disappear. What's the answer? It's the X that remains, the disk that is shown. And of course it's a 1, but it's in the lighter color, or the unshaded one, which must mean a positive 1. So that is fairly straightforward. If you wanted to be real fancy, you could do it the other way around. You could give the kids the opportunity to write the problem and the answer. I want you to write the addition problem represented by the following. Now, you could be real fancy and use your colors if you wanted to, or you could use X's, but this time they're only recording the problem and the answer. So if I keep filling these in, I want you to tell me what the answer is and how you know this. So I'm going to just do this problem, and we would ask the kids, write down the problem represented here and the answer. So when they hold up their communicator, obviously they would show that negative 5 added to a positive 2 is equal to a negative 3. And again, you could then act that out by grabbing the 0 pairs, pointing out, of course, this is your negative 5 because it's 5 reds, and the 2, positive 2 being the yellows. But I'm going to take my 0 pairs and get rid of them. I can drag them off, or I can just delete it, and my answer has to be negative 3 because there's 3 red ones left. Okay, one of the most difficult things for us to do is to get kids to subtract, and the beginning ones here are not that hard to subtract. It's the ones like this. Well, let me do one. If I have a negative 7 and I want to subtract a negative 3, that's pretty easy to do. So let's model that. I'll use my X's this time, and I'm going to put down 1, 2, 3, 4, 5, 6, and then 7. I think I'm going faster than I'm talking here. So I have 7, and I want to remove 3. I want to physically remove 3 from my model. I can highlight 3 of them, remove them, delete them, and my answer's got to be negative 4. So I'm physically moving them. Notice no rules here, folks. I'm modeling the answer. We'll get the rules later is the way this lesson develops. But anyway, you delete this, and now it's the tough one here. Is I have a positive 5 and I want to remove from a positive 5, or I want to subtract a negative 3. Almost seems like an impossibility, but let's do it with the X's or the reds and the yellows first. I think what we'll do is model this, and the kids would model this again on their sheets. I want to go with a negative 3. Let me do it the other way around. My bad here. What I want to do is I want to show a positive 5. So I'm going to put down 5 discs on my yellow, on my lighter unshaded discs here, and I have 5 now. Alright, now what I want to do is I want to remove 3 red ones, because negative is 3. I don't have 3 red ones to remove, but I do know the power of 0 pairs. I do know that if I add a 0 pair, it doesn't affect that. That's still positive 5. So if I add 1 0 pair, I can add another 0 pair, and I can add another 0 pair. So in essence, what I've done here is I still, even though I have 3 0 pairs here, I still have a what? A positive 5 represented. I haven't changed that value at all. But what does that afford me to do? That now introduces into the set, it introduces 3 red discs, or negative 3 if you will. So what I'm going to do is I want to remove minus negative 3. So I'm just going to highlight this, and let's move out my 3 red ones, my negatives, and I delete those to get rid of them. And what am I left with? 1, 2, 3, 4, 5, 6, 7, 8 yellow ones. So I know the answer must be 8, and with a positive because they're yellow. What a great way for kids to model subtraction. And finally, we can show a little bit about multiplication. Let's be a little careful when we do this with multiplication. But let's do it by groups of things. Just some basic multiplication problems. You can't really show them all. But you can show I have 3 groups of negative 4, let's say. So what you can do is you can show 3 groups of negative 4. Let's do that with X's and have the kids do it on their paper. So I have, remember, your darker discs or your shaded discs are your negatives. So I have 3 groups of negative 4. That's 1 group of negative 4. I can clone that, and now I have 2 groups of negative 4. I want to clone it one more time, so I can show 3 groups of negative 4. And now I can count them up. I have 4, 6, 4, 8, and 12, and they're all negative. My answer must be negative 12 for my answer. But you got to be careful with this. You really can't model negative 3 times 4. You can do it as the inverse. As the commutative property. But again, what a great opportunity for kids to act out using discs. Now, a lot of teachers say they would rather just use this model than even passing out the discs. A true constructivist like me would say, no, that's not really a good choice. You really want to use the discs first and then transfer to the icons. Concrete, iconic, and symbolic are the ways you really want kids to see problems.